Hamburg Port, located in the heart of the Hamburg city, is the port where the technology of the fourth industrial revolution is best applied. It is in collaboration with the global IT company Cisco 2025. Hamburg Smart Port project is designed to optimize the existing port infrastructure and minimize the port stay time of logistics companies. If you look closely at the port of Hamburg, the following technologies are grafted. The load traffic control room pulls various streams of data to predict travel time into terminals and suggests the alternative routes when traffic is heavy. In addition to traffic sensor, data sources include the schedule for bridges being raised and lowered, the situation at the container terminals, and other sources as well. To decrease accident rate of ship collision, IoT sensors are applied to on the bridge, ship transportation means, and signal is automatically transmitted when the ship approaches the bridge. The ship can pass without the stoppage. Next, with the goal of completion in 2040, Singapore's Tuas Future Port, it is very tremendous volume of the port. A global transshipment port under construction is expected to have the following main functions. First, it is connected the community, that is, the port are integral component of an extensive global supply chain which comprises of other members such as shipping lines, border, third-party logistics, warehouses, and trucks. Second, it is machine-augmented workforce which will free up capability in a skilled workforce by the artificial intelligence, robotics, process, automation, and integrated application software. Third, that is automated container handling, which is to improve the safety, productivity, and well-being of the port workers, like a machine-assisted solution as the future. Fourth, smart engineering to be able to sensor, respond, and enable the execution of the new capabilities for machine and equipment. Fifth is orchestrated operation with data analytics, machine learning, AI, and simulation. A huge data from port operation equipment can be harnessed to achieve consistent and sustained high productivity, asset utilization, and customer service levels through data-driven decisions. The final one is preemptive health, safety, and security. Health, safety, and security risk in ports will be addressed preemptively or in real time by infusing surveillance systems. Truck platooning is discerned as the future of the transportation industry. In a truck platoon, multiple trucks travel at the aerodynamically efficient distance and drive cooperatively by maintaining the distance. The global truck platooning system market can be segmented based on component, technology, vehicle, and region. Research and attempts on such truck platooning are actively taking place in Europe and United States, especially Singapore Tuas Port also is being adapted this system. In this regard, please take a look at the video footage of truck platooning in Europe.
Europe is growing, and so is one of the most important drivers of our economy and society, the transport sector. By 2025, around 70% of all freight transport will travel on public roads and place enormous pressure on European highway infrastructures and the environment. If we do nothing, the congestion costs will rise by 50% by 2050. And on top of this logistical challenge, we're striving for a greener transport sector. How will we tackle these challenges? One high potential solution is truck platooning, trucks slipstreaming very close behind one another. Truck platooning is made possible by using a combination of different technologies. Equipped with radar, camera, and GPS technology, the trucks know their precise location. The trucks communicate by wireless vehicle-to-vehicle communication, which reduces their individual response times to almost zero and allows them to drive very close together safely. Truck platooning has many advantages. Platoons take up less space and don't overtake. In the future, platoons as a whole may overtake one another, in particular in hilly terrain. This optimizes road activity and minimizes traffic jams. Driving so close together also decreases the air drag, resulting in less fuel consumption and fewer CO2 emissions. The first pilots and experiments were successful and looked promising. But how do we put truck platooning into practice on a large scale within the foreseeable future? The only way is through intense multidisciplinary collaboration on the part of the various stakeholders. First of all, the technology needs to be further developed and optimized to assure a stable and safe wireless connection between the trucks. Standardizing communication between the trucks will also allow trucks of different brands to form platoons. Safe interaction with other vehicles is also of vital importance because the platoon must be able to respond to traffic. Thanks to traffic prediction and dynamic gap distance, the platoon will be able to adjust to traffic situations and weather conditions. Every platoon can be identified by special warning lights. But it's not only the technology that needs development. We also need to adapt international legislation, which regulates factors such as the permitted degree of autonomy and allowable driving time. The number of roads where platooning is permitted will be significantly expanded between 2016 and 2025, beginning with national motorways and 10T corridors, utilizing ITS infrastructure where possible. The logistics and operational aspects will also need to be properly regulated. A platooning service provider will be responsible for certification and act as the central traffic coordinator for the truck platoons. In due course, this will also allow other trucks to join the platoon on the fly. What's going to happen over the next 9 years? We will move forward by teaming up and implementing pilot projects. When we share our knowledge, experience, and ambitions, we'll overcome all obstacles. Because the only way to sustainably improve the future of our transport is by working together, shaping a new reality, creating next-generation mobility.
From now on, we will look at the autonomous ship related to the fourth industrial revolution that can affect maritime, ocean, fishery, and shipbuilding. Before entering, let's take a look at the future autonomous vessel imagined by the Varchilla, like this.
Welcome to our future. You don't need me to remind you about the past. Things happened that made it crucial to save the planet and to make shipping sustainable. The exploitation of natural resources forced us to develop new methods in renewable energy and marine transportation. We experienced many changes, and this is how shipping became clean and successful once more. Vessels were navigated by remote control, and close-by sailing saved lots of energy. Ships were never empty because they shared assets. Maintenance was done at sea with the help of artificial intelligence. Ships entering harbors were moored quickly by a swarm of battery-powered drones. Drones were recharged in wireless powering stations using clean energy. No black smoke and no emissions. Ship owners were no longer obliged to buy ships anymore. They leased them. And all those vessels were equipped with state-of-the-art batteries that were charged during their sail across the oceans. They offered door-to-door transport services. No emissions, no downtime, no capital expenses. And finally, shipping went under the surface. Goods were transported in large submerged vessels with low energy consumption. When they needed to refill, they did it from the hydrogen hubs in the ocean. Now my passengers are enjoying a cruise in a green environment in one of the nicest places on the planet. We do this using only natural energy sources and reusing all waste on board. Now they are re-embarking and we will continue our journey. I hope you will be able to join us in our joint exploration of the future. Wärtsilä connects the dots to the future.
The long journey for autonomous vessel is predicted by major classification societies or organizations as shown in this slide. Post the war in 2020, remote sports will occur due to limited function, which will reduce the number of crew members. In 2025, unmanned coastal ships controlled remotely will emerge. Ocean sailing ships controlled remotely will emerge in 2030. And ocean sailing ships capable of unmanned autonomous navigation will emerge in 2035. The table below shows the main segment required in the process of going to an autonomous ship, namely support service method, connectivity, software, and shore automation, the degree of onshore automation, and propulsion method. The classification of autonomous ship is largely divided into ships running underwater or running on the waterway surface. And the autonomous ship mentioned now refers to a ship that travel on the water surface, that is a maritime autonomous surface ship. We call it the MASS. IMO is currently assessing existing IMO instruments to see how they might apply to ships with the varying degrees of automation through the regulatory scoping exercise on maritime autonomous surface ship MASS in 2017, following a proposal by a number of member states. IMO's Maritime Safety Committee, MSC, agreed to include the issue of marine autonomous surface ship on each agenda. This would be in the form of a scoping exercise to determine how the safe, secure, and environmentally sound operation of maritime autonomous surface ship may be introduced in IMO instrument. Existing international conventions, including Safety of Life at Sea, Convention on the International Rules for Preventing Collisions at the Sea, Prevention of Pollution from Ships, and the standard of training, certification, and watchkeeping for seafarers all were drafted on the assumption there is a crew on board. The MSC recognized that IMO should take proactive and leading role given the rapid technological development relating to the introduction of commercially operated ships in autonomous mode operating without crew. Looking at the history of autonomous ship, the European Mooning project from 2012-2015 was the first visible study. The project was to evaluate whether the Handymax bulk carrier could be converted into an autonomous vehicle. However, it was confirmed that the results were not realistic in terms of a commercial point of view. Next is the world's first autonomous container ship built by Norwegian fertilizer company Yara, which is scheduled to be in service in 2021. However, the ship's service itself has been temporarily suspended due to the influence of COVID-19. Many people are dubious about the possibility of autonomous ships. There were questions to maritime professionals, as you can see on the slide regarding the introduction of autonomous vehicles. As a result, 72% of the opinions that at the time point of autonomous ships to become generalized for commercial use will be possible within 20 years. And 79% of the experts said that the first autonomous ship will appear within 10 years. In this regard, let's take a look at the autonomous haulage system of Rio Tinto, an Australian mining company.
In mining, autonomous means a very controlled process. So it's about reducing the variability and making everything work as it should.
A couple of the advantages that customers report is an increase in productivity and reduction in their total cost of ownership.
One of the biggest benefits is the truck. The truck itself is very reliable, the best truck in the market. It just consistently runs. We have customers with the same trucks running for more than 10 years.
The safety factor, it certainly reduces the number of operators and exposure to the mining environment. You know, when mines commit to autonomous, they're putting all their trust in you. I think the biggest thing we have really is the experience. You don't just go out and put this system in. The experience that we have, we can bring that to these mine sites and make them successful.
We try to work with customers from the onset all the way to the actual implementation so that we can give them some tools and leverage our experience in the market to help them manage through those challenges.
People can learn new things and be part of this. We want people to be part of this journey as well. I think it's a space for everybody in this.
So, what is the need for innovations such as autonomous ships? It is because disruptive innovation is needed to meet expectations of ship-related stakeholders, namely ship owners, cargo owners, shipping lines, port operators, regulators, suppliers, shipbuilders, and classification society. Value proposition according to ship automation and autonomy can be divided into ship operation and logistics and vessel maintenance. Ship operation and logistics is again divided into fuel and energy cost and time efficiency. And vessel maintenance is divided into maintenance and time and maintenance. With the help of various functions and equipment, these separated parameters can reap economic benefits in energy saving, fuel saving, or loss prevention, port time reduction, OPEX, operation expenditure reduction, and unplanned downtime reduction. In addition to the economic benefits through value proposition, autonomous ships have the following advantages: improved working conditions, lower damage-related costs, reduced crew costs, reducing the risk of piracy, new ship design, and slow steaming, better environmental performance. What is the related industry doing for autonomous ships with the economic benefits and advantages? Although human trafficking is difficult due to the COVID-19, now various conferences were held throughout the year in preparation for the era of self-driving vessel, as shown in this slide, especially in Europe until last year. Also, you can see the field of interest are very diverse. In particular, topics related to legal implication, piracy, cybersecurity, impact on maritime workforce, and human factor in the era of autonomous vehicles are attracting attention. Looking at the type of ship's autonomy, it is classified as a slide according to the degree of automation and whether the crew is on board the ship or whether the crew is in the wheelhouse. In fact, the current situation is a form in which the crew makes decisions directly in the wheelhouse. But if all decisions are made in a situation where the crew does not exist at all, it is considered to be a perfect autonomous ship. The process that must go through until the autonomous ship is completed is the application of e-navigation. According to the United Kingdom's Marine Accident Investigation Branch, navigational error and failure, including those of the human element, had been significant in over half of the incidents. Accidents related to navigation continue to occur despite the development and availability of a number of ship and shore-based technologies that improve situational awareness and decision-making. This is the reason why e-navigation is necessary. E-navigation is the harmonized collection, integration, exchange, presentation, and analysis of marine information on board and ashore by electronic means to enhance both navigation and related services for safety and security at the sea and protection of the marine environment. The overall configuration of e-navigation is shown in the picture on the slide. IoT sensor attached to many equipment such as ship's main equipment, auxiliary engine, main engine, boiler, voyage data record, radar, ACDIS, BMS, cargo crane, etc. Constantly send signals such as their pressure, temperature, level, etc. to the computer server in the ship. These data are delivered to a fixed server on land in real time through highly efficient satellite communication. The ship's data stored in the onshore server can be tracked for abnormality with the help of AI and, if necessary, feedback to the ship in real time. These series of actions meet the needs of various stakeholders mentioned above, and the generated information is also donated to the necessary parties. Okay, I will finish the third slide on this slide. See you next slide.